at last class we were talking about like activity diagram. So activity diagram basically focuses on various actions, the various activities that takes place while using the system. Okay, so it activity is basically a state with respect to what are the internal actions or activities can take place, okay, while using a particular system or a software. So it's very much handy when it comes of using when you are writing or making software requirement specification SRS while making the system, it becomes much more. Activity diagrams are basically used in business process modeling in a day-to-day activity. I mean, it's an industry, okay, so it has a very much industrial kind of approach. So that is very much good, and that's why in industry you will be using these UML use cases, decision trees, activity diagram, okay, sequence collaboration diagram in a large extent. So one has to know how to make them very nicely, very neatly. The concept has to be clear of how you are going to construct, and you need to show the flow of activities that takes place. That if you remember that we have taken an example of the admission procedure of a college or an institute. So if you look here, a college or an institute will have various like sections or activities that would be taking place. First is the academic section, which will basically keep track of all the student records, isn't it, who have taken admission. Account section will be there, okay, who will be basically be looking into the payment of fees. So until and unless the payment of fees is not done, that means what, admission has not been confirmed, isn't it, in the college. So once the fees has been received, then only accordingly the other activities will be taking place in a simultaneous way. Like hostel allocation will be there, okay, hospital tie up of the college with whatever it has. So those entries of students who have paid the fees will be given to the hospital as well, so that if there is some kind of emergency related to health issues, then that hospital can coordinate. Then departmental registration also is there. Suppose if a candidate has taken admission into the university, but the university may have certain many courses, and many courses will run under different departments, particularly the student will belong. So that will be basically be understood when he has like when he has confirmed his admission by via payment of fee. So again, once he has paid the university fee, hostel will be allotted accordingly. For the hostel, there will be some hostel or mess dues, and then once this is paid, and then the rooms are being allocated. Similarly, for hospital also, you need to create the OPD for the students, so that if there is some problem, the hospital can come, okay, conduct medical examination and so on. For departmental only, we need to register for the courses. Now, when all these activities are carried out, all are completed, then accordingly, what will happen when all of them are completed? If you see this line means what? All has to be completed. They are connected, isn't it? When all of them have reached the end point, that means all the activities has been completed, then we can generate the ID card to the particular student, and then the activity will stop with a symbol like this. Okay, so this diagram basically represents the activity that of a student admission procedure at the university. So activity diagram is very much important to understand the flow of actions that may take place, okay, while making a system. If activity is clear, then only if you go for making the DFT, it becomes much more stronger. Similarly, using the activity diagram also, you can use this to construct UML or use cases in a mobile application. So that's how activity diagram is very much helpful. Now, what is the difference between a flow chart and an activity diagram? Because this is also somewhat, it's trying to understand the sequence of how the activities will take place. So if suppose someone asks you, like, what is the difference between activity diagram and flow chart? Then in that case, you can say that activity diagram actually supports description for parallel activities. Like for example, here in this instance, if you see here, okay, in this case, if you see here, like here parallelly, so many things are going on. At one side, hostel allocation, hostel fees, allotment of room for the hostel is being done. Similarly, at the same period of time, isn't it? The timeline is same, right? Creation of hospital record, conducting medical examination is also being done. So flowchart does not give that flexibility to show you the various activities taking place okay, through it. But in activity diagram, that parallel activity description and synchronization becomes much more easier to represent. Okay, so that becomes much more clearer, and it's helpful also. Okay, then next comes is the state chart diagram. Now this is basically used by finite state machine that you have done in TOC. Okay, in a state chart diagram is usually used to show the state of an object that changes with respect to the inputs received. Okay, uh, so you don't have this actually in your syllabus, but just if you remember what are the things you may have in a state chart diagram in finite state automata, isn't it? The initial state, the final state, then depending upon the inputs, intermediate states, and then there is the transition. That means the arrow marks between the two states. Okay, so something like this. So this, let us take the example of trade house automation software. So as you know that processes are represented by circles or maybe something like this. Okay. So suppose if the order is received, so what will happen? First of all, it will see, okay, like the unprocessed order. If suppose that order for any kind of, let's say, what kind of this is there? Okay, trade house automation software. So maybe some trading of garments you can say is taking place. So if suppose through the software on app order has been received, so initially first the order will be checked whether it will be accepted or it will be rejected, isn't it? So accordingly, the order will not be like it will be first cross checked whether the items are available or not. All those things you could have. Uh, you could have one can check. Okay, so one state is that the order be rejected because the items may not be all available, or maybe some problems are there. Okay, or let's say that item was available earlier but now it is not there anymore. Okay, the vendor who was communicating through that platform has taken off. Okay, and it is not supplying, so it will come to the end. Or if the order is accepted after checking, okay, the stocks are available, or maybe they can contact the trader and get the stock. So what will do, the user will get the notification that order has been accepted. Okay, now once suppose for example the items again will be processed, that means they will check if all are available or not. So if all are available, then it's good only, then they will come directly to this state, that is fulfill order, isn't it, if all items are available. Okay, and it will go out for delivery. But however, if all the items are not available, then what will happen? First of all, they have to contact the vendor how much amount is still not available, so order will be pending. And once all the items are available, then what will happen, it will go to this state which will say that all items have been procured and we can fulfill the demand that is there. So once we have fulfilled, then it will be processed and it will be out for delivery, and we can say that we have reached the dead end. So if you see here, this is the somewhere like the final state. Okay, here, which is the final state, this is the initial state that it has taken place, the black color completely, and this is the final state. Okay, like two concentric circles are there, no? The interior one is black. Okay, so this is the final state, and that the upper one, the first one is the initial state. These are the intermediate states, the states which are there in between. The arrows are the transition from one state to another. Like for example, from accepted order, it can go either to pending order or it can go to fulfill order, depending upon the availability of items. If all items are not available, then that has to be like it has to be hold before giving delivery, and the trader has to be contacted for giving the item. Once all the items are available, then we can go to the state that is fulfill order, and we can like reach to the final state. Okay, so this is somewhat represented like a finite state automated. And what kind of finite state automaton is this? It is a NDFA, non-deterministic finite state automaton. Why? Because from one, let's say, is it a non-deterministic finite automaton or deterministic finite automaton? Can anyone tell me? It is an NDFA or DFA? In this case, it is DFA only, isn't it? Because if it is NDFA, then for the same input, it will be going to different states. But here, if you see, from every input, okay, it is going to a single state only. So this is a DFA, deterministic finite state automator. Okay, so here again, there the differences between activity diagram and state chart diagram is shown. Okay, so activity diagram is like a flow chart only, but just the only difference in activity diagram is that parallel activities can be shown. Okay, whereas in a state chart diagram, it will just show you how the machine actually will work depending upon the inputs that are being received. Okay, so that is the difference basically. Activity diagram is a special case of state chart diagram in which all or most of the states are activity states only. And almost all or most of the transitions are triggered by completion of activities in the core state. So in the activity diagram, the focus is on the activities that are being taken place, okay, and how the movement from one activity to another activity is being done based on the triggering of the actions. If suppose from one activity is completed, then only it can go to the next activity. So the triggering of the completion of activities basically will make the activities to shift from one activity to another activity. But in state chart diagram, it is not so. The moment the inputs change, the states also will change. Okay, it doesn't wait for the completion of the, okay. Activity diagram actually is very easy to visualize, to say what we want, okay, and to document also. All right, but state chart diagrams are a little bit more on the technical side, but it is much more easier to understand what are the classes you need, what are the use cases, okay, you need. So it's much more from the technical point of view. That is much more helpful. Okay, so that is basically the way how you have to design your system. So as I said in your project also, okay, so let me say once again, in your project also, first of all of you who are like first finalize the title. I've seen you have finalized most of you. Apart from that, you try to lay down the objectives of your system. What are the activities it will be doing? What are the like operations your systems will be performing? Okay, like one objective may be to like keep track. Let's say if you are doing an attendance management system, what can be the objective, the aim or the goal of making the system? First goal is that to automate the attendance maintenance of employees, isn't it? That is the first goal. Second goal, it can be like to what can be the second goal? To eliminate the paper method and can go to a completely a digital kind of a platform, isn't it? Something like that. Okay, then what are the operations that will be there? So you can add record of the attendance of the students. That way you can delete, okay, you can update also. If suppose someone has not responded and has notified you that sir, I was present in the attendance, like in the class, but you did not give me attendance. So what will happen? You can update also. So some update operation can be carried out. So all those things you have to write it down explicitly in the objective. So once your objective, you have written it down, then after that, you have to go for the this analysis and design phase. So in the analysis phase, whenever you are analyzing the system, that means you are in the process of discovery. What are the things you will be doing? So what you need to do is you have to write down the SRS. You have to lay down the SRS, software requirement specification. Like from the name itself, we know that software requirement specification means what? What are the requirements the software will be having? You have to write it down. I have already taken two classes on SRS, isn't it? The format also I shared with you all. So according to that, you have to brief the this thing. Like you have to write it there point wise. What are the requirements that the softwares will be having, and accordingly you have to write it point wise. So this is very important. Once you have written the software requirement specification, then I would advise you that each one of you make the activity diagram. This is very important. Okay, what are the various activities that the software will be performing? Activities means what? The work the software will be performing. Then you make the DFD. Okay, and one more thing I'll tell you. Before you make the DFD, if you want that your DFD data flow diagram should be correct, you do one thing, you design form in a paper. Okay, In a paper, like in with pencil and copy, you design the form. Like this is my home page. In home page, I will have user ID and password. Then there will be an OK button. If I click on the OK button, then another form will open. There, all these like name, like registration will be there. Log, all those things will be there. Update details of process will be there. So you do. Then if I click there, then again it will open another page. That way, if you make, then your data flow diagram or DFD will never be wrong. So that thing has to be made in the paper, first of all, so that you can visualize of what you are going to do. Okay. Secondly, I would advise that once you have made the DFD, then I think making the ER diagram is not very easy because you will be knowing what are the internal entities which will be there. Okay, you know already what is an external entity and what is an internal entity. So external entity basically is taken care in DFD. That means the entities or the objects which will be interacting or making use of the software are the external entities. Internal entities are those are the objects which will be making use of the system indirectly somewhere. Are you getting the point or not? Or they will be associated with the system. So those things will be taken care in the ER diagram. If suppose certain entities which do not come directly, do not make use of the system directly, then that will be shown in the ER diagram. Then once you are done with the ER diagram, then you can proceed towards database dictionary because most of the tables, once you have made the ER diagram, the tables will be there only, the base tables which we say. Then those base tables you have to normalize. That means you have to decompose, okay, into like various normalization forms. Okay, so for your project you can normalize up to third normal form only. The reason behind this is that most of the larger projects are normalized up to third normal form only, so you need to normalize. Whereas in mobile application, you will not have DFDER, you will not have these at all, who are going for the mobile application or maybe those who are going for the research oriented kind of projects. So for those people, you can show activity diagram and you can show this thing, flow chart you can show, okay, that is more than sufficient, and maybe decision tree. So all these three things you can incorporate and maybe you can show that. Okay, so these are the things. So yes, Arbaz, tell me. Okay, okay, okay. So any more confusion on the project to any students? Because like I have said so many times, no, about the project. So any question to anyone? Because it's high time, February, you have to submit. So if you are having doubts, you ask me because this is software engineering class and software engineer, actually, if you know software engineering, then you can make the project very nicely. Not the coding part at least, but the other things like DFD, ER, project report, everything you can do it. Ask me questions, then only I'll be able to help you. So any question to anyone? Yes, any question? Okay, so I think all have got the point. Okay, so once we have finished analysis, when we have finished design, the next phase that comes is the coding. So the main aim of coding is to change whatever you have visualized in the designing of the system into code. That means now you are in the implementation phase. Okay, so how you are going to implement using a very high level language. The high level language is a language which is being understood by to because see, machine level or assembly language is not possible to write so many lines of code, isn't it? Very tough, and we will not be able to do also. Okay, so hence what we need to do is implement this with the help of a high level language. So it can be C, C++, it can be more sophisticated language like Ruby, it can be Python, or it can be R as well. Okay, depending upon the need and depending upon the skills of the one who is coding the system. Okay, so the programmers, whenever they have entered into the coding phase, they need to know the standards, they need to know the syntax, they need to know the in and out of the programming language that they will be taking. Okay, so the main advantage or the main merit of like knowing these standards of any style of coding that you are following basically is that it helps you to understand the code, and it also promotes it strengthens your programming skills. Okay. Whenever we choose any programming language, what are the various things that we have to keep in our mind so that we can consider that that is the programming language that we'll be choosing? So first thing is that is the readability. Readability means it allows programs to be written in certain ways that resembles a quiet English description of the underlying algorithms. What does it mean to say is that, let's say, for example, we take C, all right? Now, when we take C, we have already those inbuilt functions like scanf, printf. So from there, like print f, that means it's printing something, isn't it? So indirectly, it is having a underlying meaning. It is relating to English, how we speak, isn't it? So any high-level programming language that we choose for making the project or for making a software, it should be readable. That means it should be understandable by the person who will be using the programming language for. Okay, it should be portable. That means that high level language, the coding language that we are using for making the software should be cross it should be it can be implemented. It should have that feature of implementing across the different platforms. Like platform, when I say, it can be implemented in Windows and OS, different kinds of OS version, Red Hat, Macintosh. Okay, so you people also, while you make the system, you have to see that that software that you are building, it is cross independent across the different platforms. Okay, it should be having a very general approach. Okay, so whenever a particular programmer chooses a particular high level language, okay, no matter what the I mean to say, the different backgrounds of programmers, it can be like some may be a very novice kind who have just started it out, right? Learning a programming language. Some can be an intermittent. That means they are not novice, but they're not very expert as well. Okay. So whatever language you choose, it should be as such that it should be having a very general approach so that anyone, any level of programmer who have learned the language should be able to adapt it very nicely. It should have a very strong brevity. Okay, that means the language should be have the ability to implement the algorithm with less amount of code. So this is very much preferable. Like earlier times, whenever we used to write for code to multiply matrices, isn't it? So in C++, it takes a lot of like amount of lines of code to be implemented in Turbo C++. But with the discovery of Python or and Ruby or maybe Perl or even maybe R, okay, the brevity of the program of the language has been maintained. That means complicated amount of work which required so long amount of so large scale of lines of code has been reduced, okay, to very lesser number of lines of code, isn't it, in Python and R? This is the reason because they have so many inbuilt libraries built in them. Language is said to be very strong. Okay. Then error checking. Okay. So being human, a programmer is likely to make so many errors and mistakes while he is coding. Okay. So we should not run away with it, but we should have that strength, okay, to face and to correct the errors both at compile time as well as at the run time. So compile time errors maybe it may be due to the syntactical mistakes. Maybe we did not follow the syntax of the particular programming language. So if that is the case, then we need to refer and we cross check and then we need to correct it as per the syntax which is defined for that particular programming language. And if suppose we have certain issues in the runtime, that means with the semantics, with the logical, that means the software is running, it is showing you some output, but the output is not what you are expecting. That means there is some logical flaw while making the system, isn't it? So that also needs to be corrected. The next is the cost. So cost doesn't only mean just the money or the monetary aspects that is being involved, but it is much more than that. So what I mean to say is that the time, the effort that is taken for development of the system, okay, all these costs are being considered also very critical for choosing the language. Okay, familiar notation. So you should be very much familiar with the various notations that are being involved, the various reserved words that are there, the various keywords that are there for the language, the various inbuilt functions which are there. So you will be able to know only when you are like you have understood the syntax or the grammar of that particular programming language. It should be able to be very much quickly translated to different languages. Okay, it should be efficient. That means The language should be able to generate the object code or the machine level code very quickly. Modularity, the programming language should be as such. That means even if there are so many modules or so many parts of the software, it should be applicable to make use of the modules very efficiently. And the language should be very highly, like widely available across in open source, or maybe to which where you can make use of it, or maybe you can download the installer very flexibly. Okay. So next is coding standards and guidelines. So I'll not do today. Okay, this is very important from the examination point of view also. I think by December end, I'll finish the software engineering course. Okay, I'm 100% sure I'll be doing that. Okay, so
Okay, sir.
we don't have much, okay, much content left. And I have covered almost 65% of the syllabus already. So after these three sets, I'll be generating certain more sets. Okay, and these sets actually will cover the entire syllabus. Not, but it's not that you have to study only these sets for your final exam. But the study materials that I've given, you have to do it with more clarity. Okay, and I want to appoint two students.